Hello, my name is Jordan Lopez, and today I will be discussing climate change and its impact on ocean biological productivity. So, in this presentation, we will clarify the definition and the causes of climate change, such as its natural and anthropogenic causes, illustrate the roles of ocean and climate regulation, and look at the concept of biological productivity to understand our oceans. And then we'll also explore the solutions to be able to mitigate climate change and its impact on our oceans. So let's take a look at climate change. And when we talk about climate change, we're referring to the significant shift in global or regional climate patterns. And this change is not just contemporary because it has been an issue that has been shaping our Earth's history for many years. But however, what's very unique about our time is that the scale of these changes are largely driven by human activities. But natural factors contributing to climate change include variations like solar radiation or volcanic activity. But these are just part of Earth's natural climate rhythms and have been shaping our climate for millions of years. But on the other hand, anthropogenic factors have become increasingly significant in recent centuries because these include the release of greenhouse gases, the burning of fossil fuels, deforestation, um, and many carbon emissions that are being released. So today, the rapid pace of these anthropogenic changes is a primary concern as it poses significant challenges to ecosystems, including our oceans. So let's look at climate change and the oceans. So the oceans play a critical role as climate regulators because they act like thermostats for our planet. So they absorb vast amounts of heat and CO2 that help moderate global temperatures. However, this absorption has many consequences because the excess heat will lead to increased ocean temperatures that contribute to the sea level rise due to thermal expansion and the melting of polar ice. But additionally, absorbed CO2 will lead to ocean acidification, altering the delicate chemical balance that is necessary for marine organisms. And these changes in temperature, sea level, and chemistry significantly impact marine ecosystems. And these demonstrate the profound interconnectedness of the ocean and the global climate systems. So now let's understand biological productivity and its impact, because biological productivity is essential in maintaining oceanic ecosystems. And it's the process where marine life from tiny phytoplankton to large animals produces biomass. And this forms the base of the food web, because phytoplankton are particularly crucial as their primary producers. And climate change, however, is disrupting this delicate balance because warmer temperatures alter plankton growth and nutrient distribution that impact the entire marine food chain. And ocean acidification is caused by this increased CO2 absorption that adversely affects the shell forming species and further destabilizing the food web, and additionally changes the sea current modify and additionally it changes the sea currents and modifies current nutrient flow, so it affects the distribution and abundance of various marine species. So you may be wondering, why is biological productivity so important? Well, marine biological productivity is not only a critical indicator of our ocean health, but it is also a key factor in the global carbon cycle that helps to regulate atmospheric carbon dioxide levels. But the economic implications are very significant, as human communities depend on marine resources for their livelihoods and food supply. So, to mitigate the impacts of climate change and oceanic biological productivity, first, we must focus on reducing greenhouse gas emissions. And this can be achieved through policy changes that encourage the reduction of fossil fuels and use and promote the adoption of renewable energy technologies like solar and wind power. And these actions aim to slow down the rate of climate change and thereby lessening the impact on marine ecosystems. And second, establishing marine protected areas is crucial because these areas are designed to safeguard key ecosystems from human activities such as overfishing and population, giving marine life a better chance to be able to thrive despite the changing climate. However, with addressing the impact of climate change on oceanic biological productivity, this needs to include the restoration and adaptation efforts because restoration involves activities like replanting seagrass and cultivating kelp forests. And these actions help rebuild vital marine habitats that enhance the overall productivity and health of our oceans. And adaptation as for specifically like fishers, this means adjusting to fishing quotas based on latest scientific data to ensure sustainable practices. And by doing so, overfish populations have a better chance to recover and maintain a balance within the marine ecosystems. As we conclude, it is clear that the impact of climate change on ocean biological productivity is extensive and complex. The health of our oceans is intricately linked to our well-being, affecting everything from global climate patterns to food security and economic stability. Therefore, addressing this issue includes implementing informed and effective policies that target the reduction of greenhouse gas emissions and the protection of marine life. But additionally, individual choices matter because making environmentally conscious decisions in our daily lives can significantly make an impact. And together, through a combination of policy action, personal responsibility, we can work towards mitigating the adverse effects of climate change on our oceans and secure a suitable future for ourselves and the generations to come.